Welcome, gentle listener, and thank you for joining this quiet space tonight. As the world settles into its evening hush and the noise of the day softens into memory, you've arrived at a place where science becomes a lullaby and curiosity drifts at the pace of the stars themselves. Tonight, we'll wander together through the calming, ancient expanse of our home galaxy, the Milky Way, allowing its soft glow and serene rhythms to guide your mind into a deeper stillness. Before we begin our slow, soothing journey, if you feel awake enough, you're invited to like this video, subscribe to the channel, or leave a peaceful comment to help others find their way here. And now, feel free to let your awareness float gently around you. Let's begin. The Milky Way has long been a companion to humanity, stretching across the sky like a pale, luminous river. For countless generations, people looked upward when the night was at its quietest, wondering how such a shimmering path came to be. Even now, with all our scientific understanding, the galaxy still holds the same calming effect it had on ancient watchers. It is large enough to cradle all our uncertainties and slow enough in its movements to quiet the most restless thoughts. As you imagine the galaxy arching across a silent sky, you might allow yourself to settle into the awareness that, out of all the places the universe could have placed us, we drift within this gentle spiral of stars, protected by its vastness and guided by its slow, unhurried breath. The Milky Way is what astronomers call a barred spiral galaxy, a shape defined by sweeping arms that curve outward like delicate tendrils of light. These arms cradle hundreds of billions of stars and weave them into patterns that resemble the brushstrokes of an artist painting in soft, glowing pigments. In truth, if you could step outside the galaxy and look at it from afar, its form would resemble a cosmic flower turning in slow motion, its petals drifting outward in an elegant swirl. We can't see this full shape from within, but astronomers have pieced it together using faint signatures of radio waves, star maps, and the quiet whisper of hydrogen as it flows through space. The image that emerges is one of a serene and ancient structure, turning so gradually that a complete rotation requires about 230 million Earth years. A length of time almost impossible to grasp from our brief human viewpoint. Yet, that slowness is part of its comfort. Nothing in the galaxy rushes, nothing hurries. Everything unfolds according to rhythms older than our planet. Across those spiraling arms lies a gentle glow created by countless suns. Some are bright and young, shining with a blue-white radiance. Others are older, warmer, steady in their golden light. Each star contributes a tiny spark to the soft haze that stretches all the way around the galactic disk. When you look up at the Milky Way on a dark night, far from the busy glow of cities, you're not just seeing individual stars, you're seeing the collective memory of millions of them, all shining together across vast distances. Their light has traveled for years, centuries, millennia, crossing unimaginable expanses to reach your eyes. It's a reminder that even in a universe of staggering scale, gentle connections exist everywhere, linking the past to the present in a single thread of starlight. Take a slow breath and imagine Earth drifting in this sea of glowing points. We're located in a quiet, peaceful region of the galaxy known as the Orion Arm, minor spiral branch compared to the grander arms further out. It's a comfortable neighborhood, calm, stable, and ideally suited for life to grow. Astronomers sometimes compare our place in the galaxy to being nestled between hills in a gentle valley. There's enough starlight to illuminate the cosmic landscape, but not so much activity that the night becomes turbulent. We orbit the galactic center along with everything else. Stars, dust clouds, planets, and even the faint traces of comets that roam the outer darkness. Our entire solar system is a passenger on this slow-moving river of stars, drifting quietly, completing a single lap only after hundreds of millions of years. Humanity, in all its history, has only been here for the tiniest fraction of one galactic year, barely a blink in cosmic time. The heart of the Milky Way, though hidden from our direct view by dense clouds of dust, is a region of profound calm and ancient gravity. Deep in this invisible center lies Sagittarius A*, a supermassive black hole that anchors the galaxy's rotation. Despite how dramatic the phrase black hole might sound, the one at our center is remarkably quiet. It sits like an old, slumbering guardian, barely stirring, its presence known only through the slow orbits of stars circling it like luminous fireflies. Some of these stars complete loops around Sagittarius A times in decades, offering astronomers rare glimpses into the stability and patience of the galactic core. The black hole itself hardly feeds at all, consuming only small amounts of drifting gas from time to time. Most nights and most centuries it simply rests, a still point around which the entire galaxy turns. The galaxy's serene structure is made even more beautiful by the presence of cosmic dust, those tiny particles of carbon, silicates, and frozen molecules floating between stars. Though individually minuscule, together they create the broad, dark lanes you may have seen cutting through images of the Milky Way. These dust clouds are like drifting mountain ranges, soft and shadowy, stretching across thousands of light years. They absorb starlight, scatter it, and reshape the glow of the galaxy into patterns that resemble misty valleys or veils of twilight. Dust isn't just decorative, it carries the seeds of future stars within it. When enough dust and gas gather together, gravity begins its gentle work, pulling the material inward over millions of years. This process leads to the birth of new stars, forming within thick, quiet cocoons of matter until the moment they ignite with their first radiant breath. In regions where star formation is especially active, the galaxy blossoms into luminous nebulae, vast, drifting clouds of gas and dust where new suns are born. They glow in soft hues of pink, red, and blue, shaped by the energy of young stars still nestled in their cradles. Among the most famous of these nurseries is the Orion Nebula, visible even to the naked eye on clear nights. When astronomers observe it through telescopes, they see a landscape that looks almost dreamlike. Curling clouds illuminated from within, shadows and ripples sculpted by light and wind-like flows of charged particles. It is a place of quiet creation where new worlds may someday form around newborn stars. These nebulae evolve slowly, their shapes shifting over millions of years. The human mind can barely register register such movement. And yet the nebulae continue, patient and constant, reflecting the gentle pace of the Milky Way. Further across the galaxy, star clusters gather like islands of brilliance. Some are open clusters, loose gatherings of young stars bound lightly by gravity. Others are globular clusters, ancient and densely packed, containing hundreds of thousands of stars that formed more than 10 billion years ago. These older clusters act as living fossils of the galaxy, preserving the conditions of its earliest days. Observing them is like peering into the childhood of the Milky Way, seeing the first glimmers of starlight that appeared when our galaxy was young. Their stars shine with an old, steady glow, each one a reminder that the universe has been unfolding slowly and gracefully long before Earth ever existed. All through the galaxy, the interstellar medium, the space between stars, is filled with subtle, whispering matter. Though it appears empty to the naked eye, it contains vast, almost weightless clouds of hydrogen gas. These clouds drift through the spiral arms like gentle fog, sometimes forming long, delicate filaments that stretch for hundreds of light years. They aren't dense or dramatic. Rather, they move with an almost meditative slowness. Temperature changes ripple through them like faint breezes, and waves of gas swirl under the influence of gravity and magnetic fields. Over unimaginable spans of time, these clouds birth new stars, drift apart, and gather again. Their cycles mirror the broader rhythms of the galaxy, patient and deliberate. Human cultures throughout history have looked at the Milky Way and found comfort in its presence. The Greeks pictured it as a trail of spilled milk from the goddess Hera, giving the galaxy its name. The Chinese imagined it as the Silver River, a celestial bridge that separated two lovers, destined to meet only once a year. The Maori called it the Long Cloud, a pathway for spirits journeying across the night. Many African traditions envisioned it as a trail left by the creation of the world, a reminder of beginnings and connections. These stories reveal something shared across humanity. The galaxy has always offered a sense of belonging, a place where the mind can rest, knowing it is part of a wider and older story. As you imagine the Milky Way's slow, spiraling form, you may picture it as a vast, gently turning meadow of stars. The galactic disk is thin compared to its diameter, like a quiet field stretching across extraordinary distances, yet only lightly raised from one edge to another. Our solar system moves slightly above the midplane, bobbing gently like a leaf drifting on a calm, wide lake. This motion is so subtle that it takes tens of millions of years to complete even one oscillation above and below the midplane. The entire galaxy, with all its stars and gas, drifts through the universe in an even slower way. As part of the local group of galaxies, together with Andromeda and several smaller galaxies, the Milky Way moves toward a region of space called the Great Attractor. Though even this journey unfolds over billions of years, too slow for any single generation to notice. Beyond the spiral arms and dust clouds lies the galactic halo, a vast, nearly invisible sphere of ancient stars and a mysterious substance known as dark matter. The halo extends far beyond the visible disk, like a delicate cocoon surrounding the galaxy. The stars within it are sparse and faint, relics of long-forgotten cosmic events. Dark matter, though unseen, provides the gravitational framework that holds the galaxy together. It moves silently, influencing the motion of stars without emitting any light. Its presence is inferred only through the way galaxies rotate, refusing to slow down at their edges as expected. This invisible halo adds to the serenity of the Milky Way, forming a silent guardian that maintains its structure across cosmic time. The Milky Way did not always look as calm as it does now. In its earliest days, more than 13 billion years ago, it was a chaotic, youthful structure still forming its identity. Smaller protogalaxies merged together, streams of gas flowed inward, and the first stars flickered into existence. Over time, as billions of years passed, the galaxy settled into the spiral shape we recognize today. It is older than Earth, older than the Sun, older even than many of the elements that make up your body. The carbon in your breath, the calcium in your bones, the iron in your blood, all were forged in ancient stars that lived and died long before our solar system formed. Every inhale is connected to the galaxy. Every heartbeat carries the memory of stars. As we drift deeper into this night's journey, imagine the Milky Way not as something distant and unreachable, but as a quiet environment surrounding you, a comforting backdrop to all of human existence. Every night sky you have ever seen is shaped by its structure. Every constellation you know is placed along its broad canvas. Even when clouds cover the stars and city lights brighten the horizon, the galaxy remains overhead, calm and unchanged, waiting patiently for the next clear night to reveal itself again. In the peace of this moment, let the thought resonate gently. You are part of this vast, luminous structure. You are carried within its spiral arms, held in its gravitational embrace, and shaped by its ancient history. The galaxy moves slowly, changes slowly, and yet it is constantly creating, constantly renewing itself. Over billions of years, stars are born, burn quietly, and fade into darkness. Nebulae drift, expand, and collapse. Clusters dissolve. The spiral arms curve in their patient arcs. Through it all, the Milky Way remains a symbol of continuity, a reminder that the universe follows its own serene rhythms, far removed from the urgency of human life. As this part of our journey draws to a gentle close, feel free to let the image of the galaxy continue to glow softly in your awareness. You may picture its spiraling arms turning ever so slowly, like ribbons floating in a mild, cosmic breeze. You may imagine Earth within the Orion arm, drifting safely along its orbit, surrounded by the ancient calm of billions of stars. And you may allow that feeling of vastness, stability, and quiet endurance to settle around you like a warm, soothing night. As we continue drifting through the quiet vastness of our galaxy, imagine the Milky Way stretching around you not as a distant spectacle, but as an environment you inhabit every moment, a cosmic landscape that has shaped Earth and every living thing upon it. The glow that arches across the night sky is only a sliver of what surrounds us, the visible edge of a sprawling, luminous disk composed of worlds, suns, and drifting dust. When we gaze up at that soft band of light, we're actually seeing our own neighborhood from inside, much like standing in the midst of a gentle snowfall and watching the flakes gather in a halo above. The stars that appear as a pale fog are so numerous and so far away that their individual sparks blend together, creating a continuous river of brightness. This quiet familiarity has been a presence in the human story for as long as eyes have opened under the night, and even now, understanding its structure adds an extra layer of serenity to that ancient relationship. From where we sit inside the Orion Arm, our vantage point allows us to gaze through the densest part of the galactic disk toward the core. That bright region of the Milky Way in the direction of Sagittarius is filled with stars packed more closely together than in our outer neighborhood. Their light overlaps and mingles, forming an inner glow that has mesmerized countless generations. This central bulge, as astronomers call it, swells outward in a soft, rounded shape, like the gentle rise of a hill in the distance. Its stars are older, quieter, and have been shining for billions of years, carrying the memory of the galaxy's earliest days. The dust clouds between us and the center obscure the view in visible light, but through infrared telescopes, that hidden world emerges in rich detail, like lifting a soft, dark veil to reveal a glowing hearth beneath. There is something soothing in knowing that even the places we cannot see are full of ancient warmth and quiet beauty. As we drift outward from the core once more, the spiral arms reveal themselves in greater detail. The arms are not solid structures, but rather regions of slightly higher density, like subtle waves moving through a vast sea of stars. When clouds of gas and dust travel through these waves, they compress under their own gravity, forming new stars in a gentle, rolling pattern. It's a bit like watching ripples spread across a calm lake, each crest shaping the water just enough to create movement without disturbing the overall stillness. These density waves move slowly, incredibly slowly, taking hundreds of millions of years to complete a single rotation around the galaxy. To human senses, the arms appear frozen in place, but in reality, they are more like slow-breathing currents, coaxing new light into existence with each gentle pass. What we think of as the grand spiraling arms, Perseus, Scutum Centaurus, Sagittarius, and the others are more like loosely wound ribbons of matter, sculpted over ages by the gravity of stars and the faint pull of dark matter. Within these arms, clusters of brilliant blue stars burn brightly, their intense light revealing regions of ongoing creation. These massive stars shine fiercely but live briefly, using their fuel in only a few million years. Their light illuminates the surrounding gas, carving out glowing shapes and casting shadows into the cosmic dust. Although this activity might sound dramatic, it happens on timescales so extended that even over the entire span of human civilization, the arms appear tranquil and unchanging. The universe has a way of placing its grandest processes into a rhythm that feels almost meditative. Further along these arms lie the great star-forming regions, the nurseries, where nebulae drift like pastel clouds. Some of the most famous, including the Eagle Nebula and its towering pillars of creation, are sculpted by the winds and radiation of nearby stars. These pillars rise like serene, shaded mountains, their peaks touched by starlight, their valleys cool and quiet. Over thousands of centuries, they will slowly erode and reshape, forming new stars deep within their dense cores. But fleeting as they are on cosmic scales, they remain steady and unhurried in the span of human lifetimes. Even knowing that these structures change over time does not detract from their sense of timelessness. Rather, it reminds us that the galaxy evolves in ways that are gentle and rhythmic, far removed from the pace of everyday life. Star formation is not the only process that unfolds slowly and peacefully across the Milky Way. Many stars live out vast, stable lifespans, burning quietly for billions of years. Our Sun, an ordinary star in many ways, is one example of this steady longevity. It converts hydrogen into helium in a continuous fusion process, radiating warmth and light outward in all directions. This process is stable and predictable, regulated by the balance between the inward pull of gravity and the outward push of energy. For stars like the Sun, this equilibrium lasts an extraordinarily long time, creating an environment of consistent brightness. When stars grow old, they change in ways that are graceful rather than sudden. A sun-like star will expand into a red giant over millions of years, shedding its outer layers gently before leaving behind a white dwarf, a glowing pearl of dense matter that will slowly fade over trillions of years. In the stillness of the night, contemplating such slow, steady transitions can feel like listening to the heartbeat of the galaxy itself. Not all stars follow exactly the same path, of course. Some are born larger, burning more fiercely and living shorter lives. Others are smaller and cooler, lasting far longer than the Sunday. Red dwarfs, the most common type of star in the Milky Way, can shine for trillions of years, long enough that none has had time to die since the universe began. They glow faintly, like tiny embers in the dark, and because they are so numerous, they dominate the quiet background of the galaxy. These small, steady stars belong to an ancient lineage, offering a sense of endurance that stretches almost beyond imagination. If a red dwarf were to whisper its story, it would be one of patience and timelessness, of watching galaxies drift, collide, and reshape themselves while continuing its gentle shine unchanged. As Earth orbits the Sun and the Sun orbits the galactic center, humanity has observed the Milky Way from countless angles, though always from inside its glowing disk. Early cultures often relied on its presence to mark directions, seasons, and even ceremonial times. The galaxy was a compass long before compasses existed, a guide that remained constant while generations rose and fell. Aboriginal Australian cultures, for example, traced dark patterns in the Milky Way's dust lanes and created stories around the emu in the sky, a constellation defined not by stars but by shadows. The Inca saw the Milky Way as a celestial river connected to waterways on Earth, while certain Native American nations described it as the path of souls, a route taken by spirits after death. These interpretations, though different in detail, all share a feeling of continuity. They portray the galaxy as something reliable, familiar, and deeply integrated into human consciousness. The Milky Way's gentle movements have also influenced Earth in subtle, indirect ways. As the solar system orbits the galactic center, it moves through regions of varying density, different magnetic environments, and differing concentrations of cosmic rays. Over long stretches of time, tens or hundreds of millions of years, these galactic conditions may have played a role in shaping Earth's climate and possibly even biological evolution. Though the evidence is still being studied, the idea itself is calming. The galaxy supports us not just through gravity, but through a quiet interplay of forces that ripple across immense scales. Like a subtle tide that moves beneath the waves, these galactic cycles hint at the deep connection between life on Earth and the cosmos surrounding us. As you imagine the solar system drifting through these regions, you might picture it as a small vessel sailing through a vast, starry ocean. Our sun carries its planets with it, held close by gravity as it moves through the spiral arms. Sometimes we travel through more crowded areas where star formation is more active and the starlight shines brighter around us. Other times, we slip between arms where the galaxy grows quieter, stars become more sparse, and the night sky darkens gently. These changes unfold so gradually that civilizations come and go without noticing them. The solar system has passed through several spiral arms since its birth, and it will continue to do so as the galaxy completes each slow rotation. This movement ties Earth to a larger, cosmic rhythm, a reminder that our planet, too, participates in the Milky Way's ancient dance. Allow your mind to picture the dark matter halo that surrounds the galaxy, extending far beyond the reach of visible stars. Though dark matter cannot be seen, its presence provides the scaffolding that supports the Milky Way's shape. It is the silent framework that prevents the galaxy from flying apart, holding its stars together in a shared gravitational embrace. Scientists estimate that most of the galaxy's mass is hidden within this invisible halo, a substance that neither glows nor absorbs light. Instead, it interacts through gravity alone, shaping the motion of stars and influencing the rotation of the entire structure. Knowing that an unseen but steady presence holds the galaxy in place can add to the feeling of calm, a reassurance that the Milky Way's stability comes from something profound and pervasive, a quiet scaffold woven into space itself. As we drift outward once more, beyond the familiar spiral arms, the galaxy gradually thins into its outer disk, then finally into the vast, dark expanse of the galactic halo. Far from the bright centers of star formation, the halo is a domain of ancient stars, many older than 10 billion years. These solitary wanderers orbit the galaxy in elongated paths, moving with the unhurried grace of long-distance travelers. Some originate from dwarf galaxies that merged with the Milky Way in ages past, bringing their stars into new orbits. Their motions preserve the memory of these ancient mergers, like soft fingerprints left in the patterns of stellar movement. Each star in the halo is a testament to the galaxy's long history, carrying within it clues about how the Milky Way grew from a young, energetic cluster of proto-galaxies into the majestic spiral we know today. The halo also contains globular clusters, those dense, spherical gatherings of old stars that hang like lanterns in the outskirts of the galaxy. A single globular cluster may contain hundreds of thousands of stars bound tightly by gravity, glowing softly against the darkness. When viewed through telescopes, they appear as radiant orbs, their cores densely packed and their outer regions thinning gradually into space. These clusters are among the oldest objects in the Milky Way, Some formed only a few 100 million years after the Big Bang. Their ages provide essential clues about the galaxy's formation, and their enduring presence creates a sense of continuity that stretches across cosmic time. Contemplating such longevity can feel grounding, reminding us that even as human life changes rapidly, the universe maintains patterns that last for eons. As we move back toward the galactic disk, imagine the interstellar medium, the thin mixture of gas, dust, and plasma that fills the spaces between stars. Though incredibly diffuse, this medium is dynamic, shaped by supernova remnants, stellar winds, and the gentle push of radiation. Over millions of years, these forces create cavities, filaments, and waves that ripple through the galaxy. The local bubble, for example, is a region of hot, diffuse gas surrounding the solar system, likely created by multiple supernova explosions millions of years ago. The Sun currently travels near the edge of this bubble, moving into a region where interstellar density gradually increases. These transitions are slow and subtle, with no direct effect on daily life. Yet imagining them can evoke a sense of drifting gently through unseen, delicate currents, a feeling not unlike floating beneath the surface of a calm sea, carried by motions you cannot quite feel. Let your imagination follow these currents as they ripple through space, shaping the soft architecture of the Milky Way. Across the disk, magnetic fields thread through the interstellar medium, guiding cosmic dust and influencing the paths of charged particles. These magnetic structures form graceful, looping patterns that extend for thousands of light years. Although invisible to the eye, they reveal themselves through the alignment of dust grains and the polarization of starlight. In this way, even things that seem intangible leave their signatures upon the galaxy, allowing scientists to map the unseen forces shaping the quiet environments between stars. The knowledge that such gentle threads connect distant regions of space can feel soothing, like realizing that even in the vastness of the galaxy, patterns of order and harmony persist. Allow your shoulders to soften as you picture these long, delicate fibers drifting through the galactic disk, weaving together the movements of gas, dust, and light. In the midst of this vast environment, Earth and its moon form their own small system of serene cycles day and night, tides rising and falling, seasons shifting in gentle procession. These rhythms mirror the larger galactic rhythms in their consistency and calm. The circadian rhythms that regulate sleep and wakefulness, the annual drift of seasons across the hemispheres, and the long, slow changes in climate over tens of thousands of years all reflect deeper patterns shaped by the cosmos. The tilt of Earth's axis, the shape of its orbit, and the gravitational influences of the Sun and Moon create an intricate harmony that aligns our biological experience with celestial cycles. Even though these influences are subtle compared to the galaxy's grand structure, they echo the same theme of patient, dependable motion. As our journey continues, imagine yourself gazing up at the night sky from a quiet place far from city lights. The Milky Way forms a soft arch overhead, its glow gently textured by dark lanes of dust and pockets of starlight. With the naked eye, you can see star clusters, faint nebulae, and perhaps even the soft shimmer of Andromeda, our neighboring galaxy. Through binoculars or a small telescope, the sky deepens further, revealing distant stars that appear as tiny points of silver scattered across velvet. The longer you look, the more the sky seems to expand, as though inviting your thoughts to stretch out, soften, and settle into the quiet immensity of space. This sense of expansion is not merely poetic. It reflects the galaxy's true vastness. The Milky Way spans roughly 100,000 light-years across, with its stars distributed in a disk only a few thousand light-years thick. Each light-year is a measure of distance the span light travels in a year, and yet even that immense measure barely captures the scale of the galaxy. The distances between stars are so great that spacecraft launched by humanity have yet to reach even a tiny fraction of the way to the nearest one. And still, despite its enormity, the Milky Way is only one among hundreds of billions of galaxies in the observable universe, each with its own structure, stars, and rhythms. The idea that our home is both vast and just a single thread in a greater cosmic tapestry can bring a deep sense of humility and wonder. As you imagine the galaxy from afar, you may picture it drifting through space like a serene, luminous island. Its spiral arms sweep outward, curling into gentle arcs, glowing softly against the quiet blackness. Other galaxies glide nearby the Magellanic Clouds, small companions tugged by gravity as they orbit the Milky Way. These dwarf galaxies are filled with young stars, and their interaction with the Milky Way creates streams of gas that trail between them, like wisps of smoke drifting on a still night. Over billions of years, these galaxies may merge with ours, adding their stars to the Milky Way's population. But these events unfold so gradually that, for all of human history and far beyond it, the night sky will remain familiar and unchanged. To imagine the Milky Way in its full majesty is to feel connected to something that transcends time. Every star, every cloud of gas, every faint shimmer contributes to a collective story that has been unfolding for more than 13 billion years. The galaxy is an ancient, serene environment, shaped by slow processes that take far longer than the rise and fall of civilizations. Its rhythms are deeper than memory, more steady than any earthly clock. As we continue through this journey, allow that sense of cosmic patience to settle gently around you, reminding you that you are part of an ongoing story, one written in the language of stars, dust, and time. And as this section of our quiet exploration comes to a close, let the thought linger softly in your awareness that the Milky Way, with all its serene expanses and ancient cycles, has cradled Earth for as long as the planet has existed. Its spiral arms have guided the sun across cosmic time. Its dust clouds have seeded the creation of new stars, and its halo has preserved the memory of distant ages. In this vast, slow-moving environment, we find not only knowledge but comfort, a reminder that even the grandest structures in the universe move with gentleness, patience, and enduring calm. As we drift gently onward through the Milky Way's vast fields of starlight, it becomes easier to imagine the galaxy not as a distant collection of glowing points, but as an expansive environment that surrounds our lives in ways both subtle and profound. Even though we cannot feel its motion, the solar system continues to travel along its orbit around the galactic center, carried by an immense gravitational current that has guided it for more than 4 billion years. Every curve of that orbit, every quiet passage through regions of interstellar space, holds a story about the galaxy's shape, history, and hidden forces. The sheer patience of these rhythms invites the mind to soften, as though listening to an ancient lullaby whispered across the stars. The Milky Way is not a place we merely observe. It is the vast, gentle setting in which every moment of human existence has quietly taken place. As we journey deeper into the galactic disk, imagine the sun and its planets drifting through a soft scattering of interstellar particles. The density of matter here is incredibly low, far lower than the best vacuum created on Earth, yet it shapes the structure and evolution of the galaxy over immense time. Hydrogen atoms, drifting dust grains, and the faint presence of cosmic rays create a backdrop that fills the space between stars. These elements flow in slow currents shaped by the gravitational influence of the Milky Way's spiral arms, forming long, delicate tendrils that resemble mist carried by unseen breezes. These structures are far from chaotic. They follow patterns formed by gravity, magnetic fields, and the rotation of the galaxy, weaving subtle threads that connect the stars into a vast, harmonious tapestry. Scientists study the interstellar medium through radio waves and far-infrared light, uncovering the faint signatures of distant clouds that stretch for hundreds of light years. Each of these discoveries reveals the gentle complexity of the galactic environment, a reminder that even in the deepest night, the universe is filled with quiet motion. Moving through the galaxy, the solar system encounters regions with slightly different densities of interstellar matter. Sometimes the path carries us through warmer, more diffuse gas. Other times it passes through cooler, denser clouds. These transitions occur over tens of thousands of years or more, creating a slow, rhythmic shift in the cosmic environment. Though these regions have no noticeable effect on everyday life, their presence shapes the long-term conditions of the heliosphere, the bubble of charged particles released by the sun that envelops the solar system. The heliosphere acts as a protective shield, deflecting many high-energy cosmic rays that pass through the galaxy. Its size and shape change gradually depending on the pressure of the interstellar medium, expanding and contracting like a quiet breath drawn over millennia. The Voyager spacecraft, now traveling at the outer edges of the heliosphere, have revealed just how serene these boundaries can be, like the transition between still air and a gentle breeze. These distant regions teach us that even the border of our cosmic home behaves with the same softness and patience as the galaxy itself. The Milky Way is also rich in structures that extend far above and below its disk. Among them are the enormous, faint arcs of gas known as galactic chimneys and superbubbles. These features are created when clusters of massive stars end their lives in supernova explosions, pushing hot gas outward in broad, gentle waves that rise above the galactic plane. Though they originate in energetic events, their evolution is slow and gradual, forming cavities and channels through which gas circulates like warm air drifting through a vast, open landscape. These movements, spread across millions of years, help redistribute elements such as carbon, oxygen, and nitrogen, the very building blocks of life. Once released, these elements mix into the interstellar medium, eventually becoming part of new stars, planets, and even living organisms. This cyclical flow reveals a profound truth. The galaxy is constantly recycling its matter, shaping and reshaping the ingredients from which new worlds emerge. The thought that our bodies contain atoms forged in stars that may have belonged to earlier generations of the Milky Way adds a deep sense of continuity, connecting us to the galaxy's slow, ongoing story. High above the plane of the galaxy, in the region known as the stellar halo, quiet streams of stars drift like faint, silvery ribbons. These stellar streams are remnants of dwarf galaxies that once orbited the Milky Way before being gradually stretched and unspooled by its gravity. Over billions of years, these smaller galaxies were gently pulled apart, their stars spreading into long, looping trails that wrap around the Milky Way in graceful arcs. Observing these streams is like reading the galaxy's memory of ancient encounters, each one a soft echo of a time when the Milky Way was still growing. Some streams are so diffuse that their stars appear almost randomly scattered, while others form distinct, delicate lines across the sky. They move slowly, their shapes changing only slightly over millions of years. These streams illustrate how galaxies evolve through gentle interactions as well as dramatic ones, weaving new structures through gravitational embrace rather than sudden collision. And in this calm blending of stars, we can see that the Milky Way has always been a dynamic, living system, not chaotic, but evolving with a patience as vast as time itself. The large-scale structure of the Milky Way includes yet another layer of complexity: the warp of its disk. Unlike a perfectly flat surface, the galactic disk curves upward on one side and downward on the other, creating a subtle wave-like contour. This warp may be caused by interactions with nearby galaxies, such as the Magellanic Clouds, or by the distribution of dark matter in the halo. However it formed, the warp adds to the galaxy's sense of gentle motion, as though the disk itself were drifting in a slow, cosmic tide. The stars and gas within the warp follow smooth, predictable paths, maintaining the same serenity found throughout the galaxy. When astronomers map this shape, they see a structure that resembles a calm, slightly tilted ring of starlight, a graceful form that reminds us that even massive cosmic systems possess an elegance shaped by deep, enduring forces. Returning to the disk once more, we find regions where stars are gathered into quiet, luminous families. Open clusters are among the most charming of these groups. They form from giant molecular clouds, with dozens or hundreds of stars born from the same material and at roughly the same time. Over hundreds of millions of years, these clusters gradually disperse as stars drift away, following their own orbits around the galaxy. Some open clusters, like the Pleiades, remain tightly bound for longer periods, shining brightly against the night sky. Observing them feels like glimpsing a family portrait frozen in time, stars that share a common origin but will someday move apart across the galaxy. The gentle dispersal of open clusters mirrors the quiet diffusion of nebulae and the slow drift of gas, reflecting the larger themes of the Milky Way: creation, evolution, and patient unfolding over billions of years. While open clusters represent youth, globular clusters symbolize age and stability. These dense spheres of stars orbit the Milky Way at great distances, forming a kind of ancient halo around the galactic disk. Their stars are among the oldest in the universe, with some clusters dating back more than 12 billion years. Within their crowded centers, stars lie so close together that they can complete a full circuit around the cluster in only a few million years, a brief moment compared to the age of the cluster itself. Despite their dense populations, globular clusters remain stable and long-lived, held together by the collective gravity of their stars. When astronomers observe them, they see structures that have survived nearly the entire history of the cosmos. Their presence reminds us that the Milky Way is built upon ancient foundations, drawing its stability from layers of history so deep that even geological eras on Earth seem short by comparison. As we move deeper into the galaxy's history, it becomes clear that the Milky Way itself is the product of countless stellar generations. The first stars to form were likely far larger and hotter than stars like the Sun, burning through their fuel in a few million years before ending their lives in spectacular supernovae. These early explosions enriched the galaxy with heavier elements, seeding the next generations of stars with the materials necessary for planets, moons, and eventually life. Over billions of years, the galaxy's composition shifted from pristine hydrogen and helium to a more diverse mixture containing carbon, oxygen, silicon, and other elements crucial for the formation of rocky worlds. Today, stars near the galactic center tend to contain more heavy elements than those in the outer regions, reflecting the different rates of star formation across the galaxy. This gradual enrichment is like a slowly evolving recipe, each new generation of stars adding flavor to the cosmic mixture until the conditions for worlds like Earth emerge. Understanding this process offers a sense of continuity and connection, a reminder that the Milky Way has nurtured life not through sudden miracles, but through patient, steady development across unfathomable spans of time. Far from the galactic core, the outer regions of the Milky Way offer a different kind of tranquility. Here, the density of stars dwindles, and the night sky would appear dimmer. Were we able to stand on a world orbiting a star in these remote territories, the spiral arms grow more diffuse, fading into the surrounding darkness. Yet even in these quieter regions, stars continue to form, though at a slower rate than near the center. The gas clouds here are more tenuous, drifting far apart like isolated islands in a vast cosmic sea. These areas provide astronomers with valuable information about the galaxy's limits and its interactions with the surrounding intergalactic medium. The sparse, whisper-thin gas that fills the space between galaxies. Observing the outer regions helps scientists understand how the Milky Way draws in new material from its surroundings and how it exchanges matter with its environment. Even at the galaxy's edge, the processes shaping its evolution remain gentle and long-lived, unfolding in the same patient cadence found throughout its structure. As we turn our attention inward again, it becomes easier to appreciate the sun's motion through this vast system. Moving at roughly 220 kilometers per second relative to the galactic center, the sun traces a graceful, circular path around the Milky Way. To imagine this speed, picture the solar system sweeping through space fast enough to travel from Earth to the Moon. in less than 30 seconds. Yet despite this velocity, the orbit feels smooth and steady, unmarked by turbulence or sudden changes. The Sun's path is shaped by the gravitational pull of the galaxy's mass, including dark matter, stars, gas, and the central black hole. Its orbit also oscillates slightly above and below the galactic plane, completing one full vertical oscillation every 60 to 70 million years. These motions create a slow, rhythmic dance carried out not by choice, but by the gravitational choreography of the Milky Way. The thought of the solar system moving so gracefully through space can be calming, like imagining oneself drifting along a gentle current in a vast, serene ocean. Across this grand structure, light travels with unwavering patience. A photon emitted by a distant star may spend thousands or even millions of years journeying through the galaxy before reaching an observer on Earth. Along the way, it may pass through clouds of dust that scatter or absorb part of its energy, subtly altering its color. Some photons encounter magnetic fields that rotate their polarization, revealing hidden information about the galaxy's structure. Others may interact with interstellar gas, exciting atoms and creating faint emission lines that carry clues about temperature and density. Every beam of light we see from the Milky Way contains within it a story of its travels, a record of the places it has passed, the obstacles it has met, and the extraordinary distances it has crossed. To imagine that the light reaching your eyes tonight may have begun its journey before the rise of human civilization is to feel the deep, tranquil connection between past and present that the galaxy provides. Let your eyes grow heavy as you imagine these photons drifting through space, carrying quiet messages from stars that have shone for centuries. Even as we consider these immense scales, the Milky Way remains a profoundly personal presence. Its light has guided travelers, inspired stories, and anchored human perception of the night sky since time immemorial. For ancient civilizations, the galaxy offered more than scientific curiosity. It provided a sense of orientation, meaning, and belonging. The Yupik people of Alaska, for example, saw the Milky Way as a path traveled by animal spirits. The Mayans viewed it as the road to Xibalba, a realm of spiritual significance. In Hindu tradition, the Milky Way is associated with the Ganges, a sacred river. These interpretations, varied though they are, share a gentle truth. The galaxy has always been a source of comfort and wonder, a silent presence that connects people across cultures and time. The Milky Way's influence extends even to the limits of our imagination. Writers, poets, and philosophers have long drawn inspiration from its shimmering band, finding in its glow a reminder of humanity's place in the grand scheme of the universe. Carl Sagan once described the galaxy as a kind of cosmic ecology, a system where matter cycles through generations of stars, creating the conditions for life. Lao Tzu wrote of the value of emptiness, a concept echoed in the vast stretches of space that allow galaxies to exist in quiet harmony. The philosopher Seneca reflected on time and patience, ideas mirrored in the slow, steady processes that define the Milky Way's evolution. These reflections remind us that the galaxy is more than a collection of stars. It is a symbol of perseverance, calmness, and the enduring nature of existence. As the solar system continues its slow journey around the galactic center, it passes through regions with subtle variations in star density. At times, the surrounding sky might appear slightly richer with stars, at others, a bit sparser, but these changes occur so gradually that they are imperceptible across entire civilizations. The galaxy's overall structure, its spiral arms, central bulge, and surrounding halo remains constant over human timescales, offering a sense of stability and permanence that few other natural phenomena can match. This constancy can be deeply reassuring, especially when considered against the backdrop of daily life. The Milky Way is a reminder that even in a changing world, some things remain steady and enduring. The sun's path will continue for billions of years, carrying Earth and its companions through the galaxy with gentle consistency. Long after humanity has evolved, migrated, transformed, or perhaps spread among the stars, the solar system will still be following its orbit, just as countless stars do. This sense of continuity weaves humanity into the fabric of cosmic time, linking our brief lives with the galaxy's immense history, whether observed through telescopes, imagined through stories, or simply felt as a presence in the night sky. The Milky Way remains a source of peace, perspective, and quiet awe. As this portion of our journey through the galaxy draws to a close, imagine once more the slow, spiraling arms of the Milky Way surrounding you. Picture the sun drifting along its orbit, carried gently through regions of starlight and shadow. Picture the soft glow of distant nebulae, the ancient clusters hanging like lanterns in the halo, the delicate streams of stars tracing the memories of old galaxies. All of these elements form a single, harmonious whole, a cosmic home that enfolds us in its calm, enduring presence. The Milky Way has shaped our history, our stories, and our sense of wonder. And as we drift further into this gentle night, those same stars continue to shine, guiding us into deeper stillness with their timeless light. As we continue our slow, drifting journey through the boundless landscapes of the Milky Way, imagine the galaxy spreading around you like a vast, intricate tapestry of light and shadow. At this point in our exploration, we've seen the spiral arms, the gentle flow of interstellar clouds, the ancient star clusters, and the steady motion of the sun along its galactic orbit. And yet, even with all this understanding, the true depth of the Milky Way stretches further still, reaching into regions where the light grows faint and the structures become subtle, delicate, and deeply revealing. Moving into these quieter territories offers a chance to settle even more deeply into a sense of cosmic tranquility, the soft awareness that the galaxy is not merely an object to observe, but a slow-moving environment that has shaped the nature of everything we are. Beyond the bright swirls of the Milky Way's main disk lies a region of surprising complexity known as the circumgalactic medium, an expansive halo of gas that surrounds the galaxy like a thin, luminous veil. Though this region is incredibly diffuse, stretching over hundreds of thousands of light years, it contains a surprising wealth of matter, ionized gas, faint traces of metals from old supernovae, and subtle magnetic fields drift through this halo in currents so soft they can only be detected through the absorption lines they imprint on distant starlight. This vast, tenuous environment acts as the galaxy's ecological boundary, regulating how gas flows into and out of the Milky Way. Over billions of years, the galaxy has slowly drawn fresh material inward from the halo, while sending enriched gas outward through million-year winds generated by clusters of massive stars. These exchanges are gentle, patient, and essential to the galaxy's long-term health. Without this slow cycle of inflow and outflow, the Milky Way would run out of the raw materials needed to form new stars. The circumgalactic medium is like the breath of the galaxy itself, expanding, contracting, and renewing in ways so subtle that even entire epochs pass unnoticed in the flow. The regions where the galactic disk transitions into this ethereal halo are especially fascinating. Known as the thick disk, this layer contains stars older than many in the thin disk, moving in orbits that are slightly tilted and less orderly. These stars may carry the memories of the galaxy's earliest interactions, possibly remnants of ancient mergers that left their signatures behind in the motions of stellar populations. Some models suggest that the thick disk formed when the Milky Way was jolted by the passing of a smaller galaxy billions of years ago, heating its stars into higher orbits and creating a puffed, gently rounded structure. Over time, this thick disk has remained stable, continuing its slow rotation around the galactic center while preserving the archaeological layers of the Milky Way's past. Studying this region is like reading the faint handwriting of history written in the motions of stars. Deeper within the thin disk, the place where our solar system resides, countless minor structures drift in and out of view. There are small pockets of gas known as high-velocity clouds, streaming toward or away from the galactic plane. Their origins are still a subject of study. Some may come from the circumgalactic medium, others from the remnants of long-ago collisions with dwarf galaxies. They move slowly compared to the galaxy's rotation, but fast enough to leave subtle marks in the distribution of matter. Over millions of years, these clouds will blend into the disk, enriching it with new material while altering the shapes of nebulae and the conditions for star formation. Watching these clouds is like watching the weather systems of the Milky Way unfold, tranquil, slow shifting patterns that reveal a delicate balance between order and change. Among the most beautiful features in the disk are the molecular clouds, enormous reservoirs of cold gas where temperatures can drop low enough for complex molecules to form. These clouds are often shaped into sweeping arcs, long filaments, or compact knots where gravity is beginning its quiet work. Though invisible in ordinary light, they glow in infrared wavelengths, revealing intricate structures that resemble fog banks illuminated from within. Filaments of gas stretch across tens of light years, each one containing the seeds of dozens or even hundreds of future stars. The physics of these clouds is a marvel of gentle equilibrium. Gravity pulls inward while thermal pressure pushes outward, creating a balance that can last millions of years before the cloud collapses into new stellar nurseries. It is within these velvety, dark expanses that some of the most tranquil stories of the Milky Way unfold, the slow stirrings of future suns, waiting for the moment when they will take their place in the galaxy's gentle glow. In regions where gravity has begun to take hold, the earliest stages of star formation begin. Dust and gas gradually fall toward the center of a contracting cloud, heating as they compress. Over thousands of centuries, the core glows faintly, warmed by the gentle friction of collapsing material. These protostars, still wrapped in their densest cocoons of gas, resemble warm embers hidden inside drifting clouds. Over time, they gather more mass, spin more rapidly, and eventually ignite nuclear fusion at their centers. For a star like the Sun, this moment marks the beginning of a stable, billion-year life. The transition from cold, silent darkness to the soft, steady glow of a newborn star is one of the most exquisite transformations in the galaxy, made all the more beautiful by its slowness. There is no hurry in this process, only the gradual unfolding of natural forces working in harmony. Closer to the core of developing stars lie protoplanetary disks, swirling rings of dust and gas that will eventually form planets, moons, asteroids, and comets. These disks are delicate and luminous, shaped by gentle collisions and the slow gathering of particles into clumps. Over millions of years, these clumps become the building blocks of planetary systems. Some worlds form close to their stars, bathed in warm light. Others arise farther out, in cold regions where ice dominates. The diversity of worlds in the galaxy is astonishing. Some planets may be covered in deep oceans, others in thick atmospheres, others in icy shells or sprawling mountain ranges. Though we know of only a fraction of the exoplanets orbiting stars in the Milky Way, the number is likely enormous, perhaps hundreds of billions. Each one represents a unique story of formation, shaped by subtle variations in temperature, density, and chemical composition. And while life, as we know it, requires specific conditions, the galaxy is vast enough to contain an astonishing range of possibilities. Farther out, on the periphery of the solar system, lies the Oort cloud, a hypothetical sphere of icy bodies extending perhaps a light year from the Sunday. These frozen remnants of early planet formation drift in quiet darkness, held loosely by the sun's gravitational influence. Occasionally, the gentle pull of a passing star or the tidal forces of the Milky Way may disturb one of these objects, sending it inward as a long-period comet. But most remain motionless for billions of years, drifting in orbits so slow that they feel almost timeless. The existence of the Oort cloud highlights how deeply the galaxy's influence reaches, shaping even the farthest regions of the solar system in ways we cannot easily see. Its icy bodies act as a distant, ancient archive of the material that originally formed the planets, silent witnesses to the earliest days of the solar system. Beyond the solar environment, the structure of the Milky Way itself reveals the subtle interplay between stars and dark matter. Though dark matter is invisible, astronomers infer its distribution through the motion of stars and gas. The galaxy rotates more quickly at its outer edges than visible matter alone can explain. This suggests a vast, spherical halo of unseen mass enveloping the galaxy like a gentle, invisible embrace. The presence of dark matter provides stability, ensuring that stars remain bound to the galaxy even at great distances from the center. Without it, the Milky Way would slowly unravel over billions of years. Instead, the galaxy remains whole, held together by a form of matter that interacts only through gravity, a tranquil, silent force shaping the grand architecture of space. Its quiet persistence reminds us that not everything important can be seen directly. Some of the galaxy's most essential components are known only through the gentlest of hints. Returning to the luminous regions of the disk, we encounter the phenomenon of galactic metallicity, the concentration of elements heavier than hydrogen and helium in stars and gas. Near the galactic center, metallicity is higher, reflecting the long history of star formation and supernova enrichment. Farther out, stars contain fewer heavy elements, providing insight into the varying pace of the galaxy's evolution. This gradient is like a soft color wash across the Milky Way, with each region telling a slightly different chapter of the story. High metallicity stars often host complex planetary systems, while lower metallicity stars may form worlds of different compositions. Understanding these patterns helps astronomers piece together the history of the galaxy's growth and the pathways through which matter has flowed over cosmic time. The distribution of elements is a quiet chronicle of creation and renewal, a map written not in ink, but in starlight. Galactic dynamics also reveal patterns of gentle interaction with our neighboring galaxies, particularly the Magellanic Clouds. The large and small Magellanic Clouds are dwarf galaxies that orbit the Milky Way in graceful, looping trajectories. Their mutual gravitational pull stretches streams of gas between them, forming long, drifting trails known as the Magellanic Stream and the Leading Arm. These gas flows extend for hundreds of thousands of light years, curving around the Milky Way like faint ribbons caught in a breeze. Over time, the Milky Way draws some of this gas inward, using it as fresh fuel for star formation. This slow exchange of matter is a beautiful example of how galaxies interact without direct collision, blending, sharing, and reshaping one another over billions of years. Even on these grand scales, the motions remain smooth and serene. Occasionally, the galaxy experiences subtle ripples caused by the passage of satellite galaxies. These ripples can warp the galactic disk, create waves in the distribution of stars, or influence the shapes of spiral arms. One such perturbation is believed to have been caused by the Sagittarius dwarf galaxy, which has passed through the Milky Way's disk multiple times over billions of years. Each passage may have left gentle distortions in the galactic structure, like soft waves spreading across a still pond. These waves continue to propagate through the disk, shaping the motions of stars in ways visible even today. Though these interactions span vast timescales, they reinforce the idea that the Milky Way is not a static object but a living, evolving system responding to the slow presence of its companions. As our journey deepens, the galaxy's connection to Earth becomes more intimate. The rhythms of the Milky Way are mirrored in subtle ways by the rhythms of our world. The life cycle of stars provides the elements that form the air we breathe, the water we drink, and the ground beneath our feet. Carbon, oxygen, nitrogen, silicon, and iron all were forged in stars that lived and died long before the sun was born. The atoms in your body were once part of ancient stars that shone in earlier epochs of the galaxy's history. Some may even have come from different regions of the Milky Way, carried into the solar nebula through the slow circulation of the interstellar medium. This deep connection reminds us that we are not separate from the galaxy. We are expressions of it, shaped by its quiet processes and nourished by its vast reservoir of starlight. Even the cycles of time on Earth reflect the galaxy's long rhythms. The solar system's vertical oscillation through the galactic plane, its orbital period around the center, and its passage through spiral arms all occur over timescales far longer than human history. And yet, these cycles may influence the distribution of cosmic rays, the density of interstellar clouds, and the conditions of the heliosphere's subtle connections that link cosmic motion to the environment of the solar system. While these influences are gentle and not directly felt in everyday life, they reveal the deep interconnectedness of the galaxy's structure and Earth's place within it. The Milky Way is not simply a backdrop. It is a system in which every component, from the smallest grain of dust to the largest star, moves in coordinated harmony. As we reflect on these grand patterns, we begin to sense the galaxy's enduring calm. The Milky Way has existed for more than 13 billion years, slowly evolving from a cluster of young, hot stars into the beautiful spiral we see today. Over its long history, it has formed trillions of stars, many of which have lived and died without ever being seen by conscious eyes. And yet the galaxy continues its quiet cycles, creating new stars from old material, enriching its composition and maintaining its graceful form. Even when we consider the galaxy's far future, the tone remains peaceful. In billions of years, the Milky Way and the Andromeda galaxy will begin to merge, slowly blending their stars in a dance that unfolds over hundreds of millions of years. This cosmic meeting will not be a violent crash, but a serene entanglement, with stars drifting past one another through vast distances. The night sky of far future Earth, or whatever worlds may exist then, will brighten with arcs of new starlight as the two galaxies intertwine. Over time, they will settle into a new structure, perhaps an enormous elliptical galaxy, carrying forward the history and memory of both. Even in this distant future, the theme remains the same: slow, patient evolution guided by gravity's quiet hand. As this portion of our journey draws nearer to its close, imagine once more the galaxy spread around you in all its serene grandeur. The spiral arms curve gently across the dark, lit by the soft glow of countless stars. Nebulae drift like clouds of colored mist. Ancient star clusters hang like lanterns above the galactic plane. Invisible threads of dark matter hold everything in place, and the sun, carrying Earth along, moves steadily through this vast, harmonious expanse. Every part of the Milky Way contributes to this sense of stability and calm, a cosmic environment that has endured for billions of years and will continue to do so for billions more. As we drift into the final stretch of our journey through the Milky Way, imagine once more the galaxy expanding around you in its full, serene majesty. At this point in the night, when the world has grown quiet and the rhythm of your breath has settled into its natural cadence, the galaxy becomes not just a distant spectacle of stars, but a soft environment of calmness, a place where thought dissolves into gentle wonder. Everything we've explored, the spiral arms, the interstellar clouds, the halo of ancient stars, the quiet center cradled by Sagittarius A times, all these elements form a living, breathing whole. They exist together in a harmony so subtle and so patient that the galaxy feels less like a structure and more like a presence. And now, as we move toward the end of this long, star-filled journey, the Milky Way opens itself once more, inviting the mind to settle deeply and peacefully into its timeless rhythms. If you were to imagine yourself floating far above the galactic disk, perhaps hundreds of thousands of light years into the halo, the Milky Way would appear as a softly glowing pinwheel set against the dark canvas of intergalactic space. Its spiral arms would stretch outward like luminous rivers, winding in slow arcs that seem to freeze in place when viewed on any human timescale. The core would shine with a warm golden hue, glowing softly through the veil of dust that hides its inner workings from our view on Earth. Around it all, the faint halo would shimmer like a thin fog illuminated by the light of ancient stars. Even the emptiness around the galaxy would feel gentle, filled with occasional dwarf galaxies drifting through quiet orbits, streams of stars tracing thin arcs across the dark, and the whisper of faint gas moving along magnetic pathways. From this vantage point, the Milky Way would look both boundless and intimate, a vast, luminous city of stars wrapped in peaceful darkness. Descending back toward the disk in your imagination, the shape of the spiral arms would become clearer. These arms are not rigid structures but moving patterns, waves of density guiding the rotation of stars like the currents of a deep, celestial ocean. Each arm stretches for tens of thousands of light years, yet within them, everything moves with slow and deliberate grace. Gas clouds drift in gentle spirals, dust lanes weave together, and star clusters emerge like blossoms on a sprawling cosmic vine. Though immense in size, the arms convey an impression of softness like ribbons of faint light caught in a slow, endless dance. Scientists map their shapes through careful observations of hydrogen gas, gravitational models, and the positions of young, luminous stars. The result is a portrait of the galaxy as a dynamic, breathing entity. Within these spiral arms lie the great star nurseries, each a cradle of future suns. Nebulae like the Carina Nebula, the Lagoon Nebula, and the Orion Nebula glow with pastel hues, shaped by radiation from young stars embedded within. Their clouds form graceful curves, dark pillars, and bright regions where gas is ionized and made luminous. These are places where the galaxy expresses its creativity, where new stars arise from the remnants of older ones. Hot, blue stars ignite first, lighting their surroundings in shimmering tones of violet and white. Smaller, cooler stars form steadily in the background, destined to live for billions or even trillions of years. The processes here unfold with exquisite patience, clouds contracting slowly, filaments gathering mass, waves of hydrogen flowing like drifting fog. It is a reminder that creation in the galaxy is rarely sudden or violent. Instead, it is a long, serene, unfolding guided by gravity's soft pull. As we journey across these star-filled regions, the stories of individual stars become a tapestry of quiet, continuous change. Some stars shine with a steady brilliance that hardly fluctuates over eons. Others pulsate gently, expanding and contracting in cycles that can last days, months, or even years. These variable stars serve as cosmic beacons, their regular patterns offering clues about distance and age. There are also binary systems, where two stars orbit each other in slow, elegant loops, their paths shaped by mutual gravity. Some pairs dance at great distances, looping around one another over centuries, while others orbit so closely that they share stellar material, creating intricate flows of gas between them. These systems remind us that even in the simplicity of starlight, there exists a subtle choreography, small, intimate motions unfolding across unimaginable time. Deeper within the galaxy, the light changes texture. Stars grow more densely packed, especially near the galactic bulge, where ages of formation have layered stars upon stars until they appear as a single warm glow. Here, the metallicity, the abundance of heavier elements is higher, reflecting a long history of stellar evolution. The stars in this region shine with a kind of aged radiance, their light softened by vast stretches of dust between the stars and Earth. Dust itself plays a crucial role in shaping the galaxy's appearance. Tiny particles of carbon and silicate materials float through space, absorbing and scattering light. This creates the dark lanes and patches visible even to the naked eye on clear nights. These dust clouds are not obstacles but ingredients, essential components that help stars form, planets take shape, and complex molecules emerge. If you follow these clouds further, you find regions known as dark nebulae, where dust is so dense that even starlight cannot penetrate. These structures appear as silhouettes against brighter backgrounds, like the ink-black Horsehead Nebula standing against a luminous curtain of gas. Though dark to our eyes, these regions are full of chemistry, forming molecules that serve as the early seeds of future planetary systems. Some of the building blocks of life, organic molecules such as amino acids, have been detected in these cosmic clouds, hinting at the ways the galaxy continually prepares, the ingredients that may one day help life arise on distant worlds. The idea of life beyond Earth is one that often stirs curiosity. Yet even this topic can be approached with a sense of calm wonder. The Milky Way contains hundreds of billions of stars, and astronomers estimate that most of them host at least one planet. Many of those planets lie in regions where temperatures could allow liquid water to exist. Others may harbor exotic environments, deep oceans beneath icy crusts, thick atmospheres filled with drifting clouds, or surfaces illuminated by faint red dwarfs. Whether or not life thrives in these places, the diversity of worlds enhances the galaxy's quiet richness. Each planet follows its own patient path around its star, moving in perfect accordance with gravity's long rhythms. The possibility that countless planets are drifting through the galaxy at this very moment, carrying their own unique landscapes and histories, adds to the serene complexity of our cosmic home. As we move further along our final journey, the galaxy continues to reveal its subtler features. The Milky Way is not just a structure of stars and gas. It is also shaped by gravity's gentle waves, known as galactic tides. These waves stretch and compress the disk, influencing the shape of spiral arms and the distribution of matter. They move through the galaxy with the same slow certainty as ocean tides on Earth, shaping the environment in ways that are too gradual to be detected in a single lifetime. Yet their presence contributes to the galaxy's long-term balance, ensuring that its structures remain cohesive and its cycles continue uninterrupted. In this way, gravity acts not as a force of disruption but as a quiet, organizing principle, a soft hand guiding billions of stars into harmonious motion. The galaxy's dynamism is also revealed by its faint streams of stars, long lines stretching across the halo, remnants of ancient dwarf galaxies that merged with the Milky Way. These streams glide along arcs shaped by gravity, forming elegant loops that trace the unseen contours of the dark matter halo. When astronomers measure their paths, they gain insight into the galaxy's shape, mass, and past interactions. Though these streams represent the remnants of distant cosmic events, they move today with the same tranquil grace as all other structures in the halo, drifting silently through space like soft ribbons carried on a wind that never changes speed. Focusing once more on the Sun's place in the galaxy, it is humbling to remember that our solar system occupies a calm, stable region in one of the Milky Way's minor spiral arms. This location has provided a gentle environment for life to evolve on Earth. We are far enough from the galactic center to avoid the intense radiation found in denser regions, yet close enough to the galaxy's bustling heart to benefit from generations of star formation. This balance, neither too crowded nor too sparse, has allowed Earth's biosphere to develop in peace, shaped only by local influences such as the sun's radiation and the gentle pull of the moon. Even the solar system's path through the galaxy has been kind, moving mostly through quiet regions with no nearby disruptive events. This graceful positioning is a reminder that the Milky Way is not only vast and ancient but also varied, offering places of tranquility within its cosmic quilt. Returning once more to the concept of galactic time, it becomes even clearer how soothing the galaxy's rhythms truly are. A single rotation of the Milky Way takes about 230 million years longer than the time since the earliest dinosaurs roamed Earth. During one orbit, entire species rise and fall, climates shift, continents drift, and the surface of Earth is reshaped repeatedly. And yet, through all these changes, the galaxy continues its slow rotation, untroubled, unhurried, indifferent to the fleeting shifts of life on individual worlds. This steady, measured movement is a comfort, a gentle reminder that the universe operates on scales so immense that even the longest human stories are but delicate flickers. The galaxy's vastness allows the mind to loosen its grip on everyday concerns, inviting a sense of perspective that softens the edges of thought. At a more intimate level, consider how the night sky has shaped human experience. For tens of thousands of years, people have looked upward at the Milky Way and seen in it a source of guidance, inspiration, and reassurance. Nomadic tribes followed its arc across the sky for navigation. Farmers used the position of its bright regions to track seasons, Storytellers drew its glow into myths that conveyed wisdom and connection. In some cultures, the Milky Way symbolized the path of ancestors. In others, it represented divine rivers, celestial roads, or the boundary between worlds. These interpretations varied, but the comfort they provided remained constant. Even now, when science offers detailed explanations of the galaxy's structure, the sense of deep, ancient familiarity persists. The Milky Way continues to be a gentle companion, its soft glow serving as a reminder that we are part of a greater whole. As the mind grows quieter and the night deepens, it becomes easier to picture yourself nestled within the Orion Arm, drifting along with the sun as it moves through the galaxy's luminous embrace. Imagine the Earth gliding through space, carrying oceans, mountains, forests, and cities along its slow path around the Sunday. Imagine the sun itself drifting through the spiral arm, surrounded by a faint cloud of interstellar material, guided by the gentle pull of the galactic center. Picture the entire solar system as a small, shining mote moving within a larger motion, part of a slow, ancient drift that has continued for billions of years. The galaxy becomes not a distant object but a cradle, a vast, soft environment that holds your world gently, allowing life to unfold in its own natural rhythm. As our cosmic journey moves toward closure, the Milky Way's features begin to blend into a unified whole. The spiral arms, the halo, the thick disk, the circumgalactic medium, the ancient clusters, the molecular clouds, the long streams of stars, all of them contribute to a single, overarching feeling that the galaxy is a place of profound calm. Every star follows a path shaped by gravity. Every cloud drifts along quiet currents. Every cycle of creation and dissolution unfolds slowly, patiently, without urgency. Even the most powerful events in the galaxy, like supernovae and black hole interactions, occur within the context of vast timescales and gentle overall motion. Nothing in the Milky Way is rushed. The galaxy's pace is the pace of deep time, inviting the mind to release its hold on the fast, fleeting movements of everyday life. As we approach the end of this long, soothing exploration, let the thought settle softly. You are part of this gentle system. The atoms in your body were shaped by ancient stars. The rhythms of your life reflect the rhythms of the galaxy. The calmness of the night sky carries the quiet memory of billions of years of cosmic evolution. Whatever changes come and go in the human world, the Milky Way continues its serene journey through space, offering a sense of constancy and peace that is always available when you look upward. And now, as the final moments of this journey unfold, imagine the galaxy as a soft, glowing river stretching across the night sky. Picture its light settling around you like a veil, calming every thought, quieting every lingering tension. Let the stars drift further into the distance, their soft glow becoming the background to your own steady breath. You are safe within this vast, ancient home. You are part of something immeasurably old and beautifully serene. Thank you for traveling through the Milky Way tonight, for allowing its gentle rhythms and ancient stories to guide you into deeper stillness. May its soft glow remain with you, offering comfort, grounding, and the quiet knowledge that the universe moves with patience and grace. Rest now beneath the galaxy's timeless light. Drift into sleep, peacefully and without hurry. Good night.